Hey guys, welcome to lesson 2 in unit 1, and we are going to go over a lot of triangle properties today and angle relationships, and a lot of this is going to be review for you, so this will go pretty quickly. I've already filled in the fill-in spots here. So vertical angles have equal measures, parallel lines never intersect, and then this is called the transversal when it cuts through parallel lines. Another thing you should have learned in geometry was the names of when you have a transversal, what happens and what's equal, what's not equal. So the one thing that I want you to remember is that you will need to know these. So I'm just calling that out right now. You will need to know the names of those for the test. But if you struggle with that and you're on a test and you're just like, I have no idea what's equal to what, don't get too tied up with these names. And I know a lot of you are probably fine with it because you've had it in geometry. But just know that you just have similar big angles and similar little angles. So every big angle that you have are all equal to each other. So all big angles are equal, and all little angles are equal to each other when you have this setup here. So you're not going to have like this be 40 degrees and this be 45 degrees, like, or I guess 140 degrees and 145 degrees. Every big angle is equal to every other big angle, and every little angle is equal to every other little angle. And if you have a big angle plus a small angle, those are supplementary. So those are equal to 180 degrees. So this is kind of nice to remember if you get lost along the way. So let's go ahead and apply this. We have these two angles here. So notice at its basic, we have a little angle and a little angle. So we're going to set those equal to each other. I've done two things. I've named it, which is alternate exterior angles. And then I've also solved for it. So I set this equal, these two angles equal to each other because they're both little angle and little angle. And I got x equals 21. So I went ahead and just plugged in the values. So I came up with this whole drawing is just made up of 65-degree angles and 115-degree angles. So hopefully that kind of reiterates what I was saying before. So the sum of the measures of the angles in a triangle is 180 degrees. And so we're going to use this for problems like this. So we're going to set it up as 48 plus 61 plus x equals 180. If you do the math, x equals 71 degrees. Okay, and something else that I'm going to add in here for part B, if you have a setup like this where you have a triangle, so I know this angle right here, I know this angle right here, and I know this angle out here, but I don't know what that angle is. That's okay. We can use the exterior angle theorem. So how I'm going to set this up is I'm going to add the two given angles of the triangle, and that is going to equal this guy up here. And then solve for x that way. So x equals -4. You can also add these two up and subtract from 180, and then these are supplementary, but using the exterior angle theorem is probably the fastest way to get there. So there are really two different ways to classify triangles. The first is by the angle, so you have acute, right, or obtuse. And then the second is from the sides. So equal angle, equilateral, isosceles, and scalene. And again, I know that you guys are familiar with that. The next thing I want to talk about is similar triangles. So the angles of similar triangles are equal. So they have the same angles, but the side lengths are going to be proportional. So let's look at example 3 here. We have a setup like this. So I know that because they're similar, angle A and angle N are similar. I also know because of the hash marks that B and M are similar, and C and P are similar. So find the measures of B and C. So angle B is going to be 31 degrees and angle C is going to be 104 degrees. Go ahead and try this one down here. So this is looking at it from the side lengths. So I noticed that when I went from 16 to 8, I was dividing by 2. So this is decreased by a factor of 2. So I divided everything and I got 16 and 12. Go ahead and take time to go through these next 5 problems and then we will talk about them. Okay, so this is showing my work for problems numbers 1 through 5. So if you have any questions at all, just let me know. Now go ahead and try questions 6 and 7. So these are my answers for 6 and 7. I wanted to point out, for example, A. B is very similar because it was just dividing by 2 again, but A was kind of a factor of 1.5. So if it's better for you to set it up as a proportion, go ahead and do that. I did it actually for both of them to show you how you would do this. It's completely up to you. For this last section, we're going to talk about the word problem side of this. And so pretty much just looking at the pictures, we have 2 similar triangles here. And so if you'll read through the question, this explains where it's coming from. And we need to find the height of the flagpole. So I'm just going to call this H. And just like I did up here, I'm going to set this up as a proportion. So find similar sides and set it up. So I think I'm going to use these 2. So I'll say 18 is to 99 as, and just keep it consistent. 10 is 8. And then just cross multiply and divide, and H equals 55. Okay, so go ahead and try these 2, and then we'll talk about it. So these 2 required you to kind of draw pictures along the way, and so I did that. I'm going to tell you that I am a terrible artist, so I'm sure your pictures look more beautiful than mine. But in these 2 cases, you can at least see it kind of made a right triangle here, and we were solving for the height of the bush. And so again, I set it up as a proportion. You have a little bit of wiggle room, so notice my thought process was X is to 27 as 38 is to 75. And same thing down here. So this one was kind of a sneaky snake problem because you have this triangle and it gave you all the dimensions of the triangle, but then it said the shortest side of the real life distance is 92. So you needed to know that 92 went with the 7. So I said 7 is to 92 as 15 is to, and then you're trying to find the longest side, X. And so that's how I came up with those 2 problems. And that is it for lesson 2.